The recording started. Welcome to week 4 of C++. If you guys are joining us in the asynchronous video, we're just getting started talking a bit about last week. We're going to do a recap, and then we're going to get into vectors and arrays today, which is just another way to store complex data. So I just wanted to give an overview of the Blackboard. I shuffled some stuff around here. This is the assignments and tests section that you can get to on the left. So all the tests, or weekly quizzes, I like to call them, you can find in the tests folder there. Any labs will just kind of be sitting on the top level surface, unless there's a ton of them. I'll group them in a labs folder. And then all our weekly assignments that we do that are worth 4% are in their own folder, and they're kind of labeled, which week we did them, and then what it's generally covering. So that errors lab we did, and then this one is due tonight. If you guys haven't done it, the week 3 constants assignment, where you have to do, I have it open here in CodeLight, the number of small rooms and number of large rooms, figure out the tax and the cost and give an estimate that's valid for 30 days. That program is due tonight. If you haven't uploaded your code, you zip your folder and then put it on Blackboard for me. Cool. And as you can see, we'll get into an assignment for vectors today. So before the end of the class, I'll introduce that. And without any ado, let's open up our weekly learning. Week 4 folder is available now to you guys. And you can see that was the link for the intro activity we did. If you guys are doing this asynchronously, you can go look at the pictures that we shared there, and feel free to add a picture of yourself in that slideshow. Here's the PowerPoints today that we'll cover, and then the code that we'll use in class to do some of our in-class code. So I'll just open up our week 3 recap PowerPoint. I've got it right here. Oh, it's from last week, sorry. 3 recap. And I'll share it on the screen. Weekly recap. Okay. So, before I do this, I'd like to ask you guys, what did we cover last week? Who remembers? So are we not supposed to submit week 3 input-output lab? Oh, input-output. Sorry, I will answer this question first. Weekly learning, week 3. The input-output lab, yes, this one. So I remind myself. 3. Yeah, that one we did in class. If you guys did it, it was great practice for you. I can create a submission portal for it. Yeah, actually, I will, just because if you guys did it, then you guys deserve to be graded for it. So actually, I wasn't planning on doing it, but I actually will. So let's just do that really quickly. Sorry, guys. So if you did do the week 3 input-output lab, I will make that due. That due tonight, so you guys can just submit it. 3 lab input-output. That was where you said how many dogs Sally had, and etc. You said hello Ben in an output, and use some variables. So due date, night, 11:59 p.m. 5 points. All right, not 5%. It'll be like 2%, but just because it's a lab, it's a little smaller than the weekly assignments. But you can find that there. Cool. Awesome. And I will just add to that. Browse local files. Sorry, guys. Just give me a second. Input, output lab. Right there. Please follow the instructions from input lab. It's attached. There we go. So it's available there to work on. Okay, good. Hoorah, Rashmi. Nice. Awesome. Okay. So, any idea? Oh, that is what we covered last week, though. Yes, input output is one of the things we covered. What else did we cover? We briefly touched on input output. Yeah, I know you just answered my question. I thought you were agreeing with Rashmeet about the submission for the lab. What did we cover after input output? Constants. Yes, thank you, Simon. Cool. And what is a constant? How is it different than a variable? Anyone remember? What would be an example where we would want to use constants in our code? What type of program or something like, what's an example of why you would use a constant? Radhen. Yeah, pi. Perfect. So pi never changes, 3.14. And if we had a program that calculated the area of a circle or the circumference, you would use the constant and then declare a constant of pi, and then you could type 3.141596, whatever, and then that would be the constant you would use, and it would never change. You can't change it after runtime, etc. Perfect, cool. So here's a little recap. We also covered preprocessor, the preprocessor program that strips all the comments from our source code, looks for the hashtag directives, and replaces them with the file it's referred to. We covered that a preprocessor directive is the pound include, pound if, pound else. We covered the main function just quickly. We talked about how you can only have one of them. It has to return 0. There's 2 types. It can pass arguments or not, and it's the starting point of a program. We talked about namespaces, using the namespace std, which reduces naming conflicts. That's why we use namespaces. Cout and cin can be chained with the respective extraction or insertion operators. And we also talked about variables and constants, declaring them with C++ list initialization syntax. So there's an example of that right there with the curly braces. The reason we do that, it's right there. I was going to ask. But the reason we do that list initialization is because it will give us extra warnings with overflow errors, right? So it's just a little bit more intuitive to use that type of initialization. We talked about the size of operator with our constants or our variables, so we can find out how many bytes we can store in an actual int or float or double, and we actually figured out what the max limit of our ints are by including that C limits or C float file. And then we kind of did a little bit of constants versus variables lab where we made a carpet cleaning service, and your guys' job was to add small rooms and large rooms. Cool, so that's our little recap from last week. Let's get into the tests folder here, and I've got this week 3 recap test that we can go through. It's 20 minutes, and we're going to do it. I'm going to listen to you guys, and you guys are going to tell me what you guys think the answers are, and you guys watching the video, you can go through it with us, and hopefully I can answer some of your questions if there's any confusion. Cool. So just get that ready. The password, I believe I have it here. Nope, that's the link. Just forget the password. It's due tonight at 11:59, by the way, if you don't do the test. If you're watching the video, do the test by tonight, okay? Week 3 recap, there's the password. I put it in the chat. It is all lowercase, no spaces, weekly test 3. Everyone ready? Just put that in there. Weekly test 3. I think the questions will all be in the same order, so we'll go through. Did you guys find it helpful when I went through it with you guys, or do you guys prefer to do it on your own? You liked it? Yeah. Okay, cool. I know obviously it's probably better for you because the marks are going to be better because you're going to get everything correct. But I actually think it's good. The marks, like these are pretty insignificant little quizzes. Like they'll be like minuscule percentages of your final grade, which is fine. If you get 100% on them, then they all will add up. But I think it's better for your learning that it will actually stick, right? And whatever misconceptions you had about something, you can figure out and we can kind of squash whatever misconceptions there are and everyone's on the same page, right? Cool. All right, I'm going to hit submit and we're going to get started. So, number 1, Simon is already on it. All variables must have a blank before they are used in a program. Simon says definition. Okay. Um, so we can rule these out pretty much. We know comments are optional. A value, why don't we think it's value? A display statement. Anyone agree with Simon? Everyone disagree with Simon? A value is after the definition. Yes. Perfect, Bura. So yeah, you have like int and then you define it, right? By giving it a name. So like int number of players or something like that. And you can actually have an undefined variable, right? Or not undefined. You can actually have a variable that's not uh, been assigned a value. And you'll get a warning in your compiler, but the code will still run. It'll say, hey, you declared or defined a variable, but it's not actually been assigned a number. So you could have a variable that's like int number of players and then just a semicolon. But then if you don't have it equal to 100 or something, then it's just declared or unassigned to a value. Perfect, that's correct. Moving on. We've got storage locations in memory are represented by, okay, blank, literals, constants, variables, or square brackets. Why do we think it's variables, guys? And I've got Simon Abura participating. That's awesome. Let's get a couple other people in the chat. I know you guys are there. Raymond, variables, cool. Let's try to get a couple other people joining in the chat here. I know you guys are there. So feel free to type in the chat. Why'd you say oh, Raymond? Do you doubt your choice now? I spelled constants wrong. Just ignore that. Storage locations. You guys are correct. It is variables. Pretty simple. Okay. String literals are always enclosed in, what do we think? Single quotes, double quotes, square brackets, or curly braces? Ura says double quotes. Double quotes by Radhen. Very good. Nice. Good job, guys. Yep. That is pretty straightforward. Thanks for participating, Radhen. Simon, yep. Double quotes. Nice. Okay, we'll do that. Okay, and character literals are always enclosed in, we've got single quotes, double quotes, curly braces, square brackets. Same choices here. Why is it different than, okay, we've got single by Bura, single by Jillian, single by Raymond. Yes, you guys are correct. It is different than strings, chars, or character literals. Literal being a type of constant is a single quote. Very nice. Awesome. We're cruising through this. A variable that can hold only true or false values is of type what? Bool, int, double, logical. Bool by Bura, Raymond, Rashmeet, Radhan, they all think bool. Okay, cool. Simon thinks bool. Nice. You're all on the same page. That's correct. Okay. Hopefully these get a little more tricky for you. The following expression determines how many bytes of storage are required to store a double on your computer. So we've got bytes double, length double, then just double, or size of double. What do we think it is? How do we see how many bytes of storage are required on our particular operating system, depending on the compiler we have installed? We did cover this. It is in the recap PowerPoint if you want to download it there. There is a reference to what function we use. Jillian thinks size of with a question mark. Simon thinks size of double. You guys would be correct to think that because bytes and length, they're not functions that would return the amount of bytes. So this would say either 4 bytes or 16 bytes, 8 bytes. Size of double is the correct answer for that one. Cool. What is the output from the following code? So we have int x, so we have a defined variable or declared variable, and there's no value assigned to it, okay? So it's just whatever. And then we do an output to the console, cout x and line. Is it going to return 0? Is it going to return null? Is it going to return some garbage value that it makes up? Or is it going to say no value in the console? What do we think? Ura thinks null. Can try this. make a little program. If we do int x, c out, someone thinks 0. Let's try it. I'll run it. It's an uninitialized variable. Oh, this actually did return 0 because I have returned 0 here. However, it is supposed to be some garbage value. Interestingly enough, for me in my operating system, it returned 0, but coutx, it actually did return 0. I put it in as some garbage value because it might not always be 0. Right now I'm getting 0. I did just run this before, this code, and it did give me garbage. But so you could say 0 and that's correct, but that won't actually give you the marks if you want it. I said some garbage value is what it should be. So you thought about it, yeah. So mine actually did do 0. You guys can run that code on your machine and see what it does. It's interesting. So I can append that in the test afterwards and make that a correct answer, but right now this is the correct answer. It should be garbage value. Sorry about that if that's a little confusing. Okay, next question. Well, it's an int, yeah. Well, I could make it something else. I could make it a double or something, but it still might be 0. There we go. So that's garbage. 7.90505 e times 10 to the power of negative 323. So yeah, let's just agree that it's a garbage value, even though it is an int. It's not actually correctly assigned the value of 0, okay? So it is technically just garbage. It just is going to assume whatever it wants about that. And you can see that with the double example there. Which variable definition is not legal in C++? Int x equals 100, int x equals 100 with a semicolon, int x curly brace 100 semicolon, int x equals 100. A and D are the exact same answer. This one, I believe, is supposed to have braces around it, but it would be A or D. Yes, one of these. One of them is correct. If you guys get this one wrong, I can just append it. I'm missing my brackets. One of them is supposed to be actually correct, so it's one of these, A or D. But if question 8, I'll just fix that. I missed my bracket. Sorry about that. But yes, good call on that, Simon. They're both incorrect. But one of them will only give you the right answer, unfortunately. So I'll just make sure I edit that. Which line in the following code, this is question 9, will generate a compiler error? So we've got code here. We're using namespace std int main. We open our bracket. We're returning 0. We've got two consts, min age and max age, 18 and 35. And then we try to change one of our consts to 21. And then we see out minimum age to the line, to the console. Bura says 8, Radin says 8, Raymond says 8. So why is that going to give us an error? You guys think it's number 8. Why do we think that's going to give us a console error? You can't see, Simon? Oh, is it too, oops, whoa. Try to zoom in there. Constants can't be changed. Exactly, Bura. Nice. It's a constant variable. You can't change a constant variable after the program has started. So yes, you guys are correct. It's 8. All right. Question 10. Data values that do not change while program executes are blank. Literals, variables, doubles, or integers. What is a literal? It's a type of what? So yes, constants are values that cannot be changed while a program executes, but that's not an option here. So what is a type of constant? Which one of these is a type of constant? We did cover this in the PowerPoint from last week. We talked there's like 3 different types of constants you can make. So there's literal constants, there's defined constants, and there's declared constants. And literals is the most common type of constant. Yes, very good. Okay, it is literals. I mean, I kind of gave that one to you guys, but nice. All right. What is a preprocessor directive? We just talked about this in the recap PowerPoint. The include. All right. And for bonus points, what is a preprocessor? Include IOStream, yes. So the preprocessor directives are those pound include, pound if, pound else, any of those. And what does the preprocessor program do with those lines of code? We did just cover this. It'll go through it. It'll strip all the comments. It's that program that runs before everything gets built. And then it looks for those pound includes and it replaces them with the code from the IOStream file or from the climits file, right? That's what the preprocessor does. Cool. Question 12. Select all of the following about the main function in C++ that are true. It returns 0 if successful. Every C++ program must have exactly one main function. If it is the starting point of program execution and can have more than one main function. So we've got 2 here that are kind of opposite. More than one or exactly one. What do we think? You can choose more than one here. So there's all the following that are true. Which ones? We can select 1, we can select 2, we can select all 4. So we know the first one is true, says Bura. It is the starting point of program execution. Okay, so we think that one is true. Okay, and then can have one or more than one. Must have one main, what Bura says. B, yes. Can only have one main function. Yeah, exactly. You guys got it. Nice. All right. Why do we use namespaces? And here's an example of a namespace we would use. A, they remove warnings in our code. B, it is required in modern C++. C, they import libraries of code that we otherwise wouldn't have access to. Or D, to reduce naming conflicts. Ura thinks it's reducing the conflicts. Who else? What do we think? Anyone else? Jillian thinks it's the conflicts. You guys would be absolutely correct if you guys think that, because basically what we're doing is we're avoiding if someone else has another program or method in a third-party library that's also called cout, right? Then we know that we're using cout from std, the standard library, not say Ben's custom library that also has that method. Yeah. So it reduces those naming conflicts. Awesome. Next question. We've got 2 more here. How do we chain the cin operator? So we've got cin with brackets facing greater than symbols. We've got cin with plus symbols. We've got cin with less than symbols. And then we've got cout with greater than symbols. What do we think it is? How do we chain? Bura thinks it's the first one. Rashmeet thinks it's the first one. Jillian thinks it's the second one with the plus symbols. Oh, sorry, she says the third one. Okay, so you guys think it's between these. So the only difference between these ones is the way the arrows are facing. So how do we remember which way the arrows have to face? See out or see in? Or not out or in, but the arrows face out or in. Out. Jillian thinks out is this way and in is this way. Simon thinks, are you thinking that that's the correct one there, Simon? This one? We got a bit of controversy on this question. Okay, So just a little catch there, Simon. There's a little bit of a trick on you. These are the right facing angle brackets or greater than symbols for the extraction or insertion operator, but we're talking about chaining the CIN operator, and this is the COUT operator there. So just keep in mind that one will be incorrect because we're trying to chain the CIN operator. So it's either A, B, or C then. We can rule that one out because it's COUT. And I think we can also rule this one out because it's the pluses, and we've never used the pluses in C++. So it's either the arrows facing this way or this way. Let's go check our code and let's go see our input-output code. What do we got here? Our cout, we've got it's smaller on the left and bigger on the right, okay? Which would mean that our cin would be bigger on the left, smaller on the right, right? So cin looks like, I don't even know. The alligator is, you know, in math when you learn about them like as alligators chewing. CIN arrows are greater than, yeah, they're eating the CIN. So it's actually the opposite way, Jillian. Out is the less than symbol, and in is the greater than symbol. Good. So it's this first one. Cout, the alligator is spitting out. You got it. CIN, the alligator is eating the CIN, if you want to remember it that way. Cool. So that is the correct one there. Cout, blah. Yeah, you got it. So then you can remember CIN's the other way. Last question, number 15. There are many ways we can accomplish declaring and initializing variables. Which way did I show you is the preferred way to avoid an overflow error and catch these exceptions? So we've got int age 21, which is constructor initialization. We've got int age, which is uninitialized. We've got int age curly brace 21 semicolon, which is C++11 list initialization. And then we've got int age equals 21, which is C-like initialization. Radhen thinks it's option C, okay, which is this one. Any other people? Any other thoughts? Any other answers? What do we think? Remember, if we do uninitialized, okay, we can automatically take that one out of the equation. So we know it's between these three. Constructor initialization, okay, we've never used that so far either. So it's between list initialization and then the normal one that we're used to. C++ list initialization, yes, Simon, good. So this is modern C++, is the modern way of doing it. You may see this in legacy code, but this way will actually give us an overflow warning. Remember, we had the example of people on Earth, and we had to do like a long int to store that number because a normal int wouldn't store it. So with list initialization, will actually give you that warning, whereas with the C-like initialization, it would just give us a garbage value because it wouldn't be able to hold that. So it is option C, and we can save and submit. And I may have, if I hit OK on the results, I may have one that was wrong because, oh no, 150. Okay. You guys may have 140 just because of question number 8, which variable is definition is not legal in C++. If you want me to fix that, just send me a quick email so I can remember and do that after class. But cool. We'll go back into the weekly learning folder once that's done. Good job, guys. Hopefully that helped clear up some stuff, and we'll get into the weekly learning this week. Cool. So I'll just go through this next PowerPoint, number 16. We're just going to move on from slide 33 in that PowerPoint. These are just from the Mirage textbooks, but all of this stuff is stuff we've covered before, like the keywords and everything, naming recommendations for variables, the types of arithmetic operators in C++, how to chain the cout and cin operator. We've all covered all of this stuff. We're just going to move from number 33 here, just because there's some stuff that I wanted to cover. And then we'll take a little 10-minute break after I go through this. Actually, there's some stuff that I want to go through in here. So we'll take our 10-minute break now. Then we'll get this open from slide 33, and we'll go through some of these things because I want to cover some of these functions with you guys in CodeLight. So we'll take a little 10-ish minute break, be back just after 12. If you guys wanted to go grab a coffee, stretch your legs. Yeah, I'll pause the recording.